Right, in this clip we're going to work through the intermediate tier progress check number 2. We're keeping the grade boundaries the same, so we're basically saying 40 plus will get you a C, 52 plus and you're into the grade B zone. So looking at the way the marks are distributed there, we've got 10 to there, 10 to there, that's 20, 30, 39. So if you get as far as there, you're looking at a C grade, 43, 46, 50, 53, everything beyond there, you're on for a grade B. So let's take a look at this first question. So Daniel wants to buy a new bicycle. It is priced at £480. He can either pay the £480 immediately or pay a 15% deposit followed by 24 monthly payments of £22. And they want us to calculate the total amount Daniel would pay using the deposit and monthly payments, and monthly payment method. And we must show all our working. So first of all we need to find out what that deposit is, and it's a 15% deposit of the cost of the bike, which is £480. So the deposit will be the £480, and we want to work out what 15% of that is. We said you can use a calculator on this question, so on this paper. So on your calculator you would type 480 times 15 and then percent. That's £72. So Daniel will have to pay £72 up front, and then 24 lots of 22. Which is £528. So the total he will pay by choosing a monthly repayment option rather than paying up front will be the 528 plus the £72. So £600. And where it says you must show all your working, that's what it means, is that you are setting out every stage. It doesn't mean that you have to go to town without a calculator and show how to find 10%, then 5%, then add them together. You would have to do that on a paper one, but if you're allowed to use a calculator, showing your working is just putting those stages down. Question 2. So this is the OCW question. Out of those 7 marks, 2 of them are for how you lay your work out. So Arwin needs to buy 4 new tyres fitted on his car. I would also like a new spare tyre. He sees 2 deals advertised at the garage. So economy tyres, £64 each. No matter how many tyres are fitted, the total fitting charge is £20. So that's not per tyre, that is for all the tyres. And then top class tyres cost £95 each, but you get a 10% discount if you buy 4 or more tyres. Arwin has exactly enough money to buy 4 top class tyres and to have them fitted. Does he have enough money to buy and have fitted 4 economy tyres with a 5th tyre as a spare? So what we have to do here is first of all work out, it's telling us he's got exactly enough money to buy 4 of these. So we can use that information to find out how much those cost, and then compare that to how many 5 of the economy tyres would cost. So for top class tyres, so for 4 top class tyres, it will be 4 lots of 95 that's £380. But he gets a 10% discount, which would be £38. So the cost would be 380 less 38, £342. Now you could have done that in one swoop by working out if it's a 10% discount, the cost is going to be 90% of 380. So the other way of doing that would have been 380 times 90%, which is also 342. And that method is a method that's more useful, if you can get your head around it, when it comes to the grade B questions on percentages further down the line. So the cost of 4 top class tyres is £342. Now we work out how much 5 economy tyres are going to cost. So that will be 5 lots of 64. Which is 320. Plus a £20 fitting charge. So the total cost would be £340. So we now need to answer the question, and the question is asking, does he have enough money to buy and have fitted 4 economy tyres with a 5th? The answer is yes, he is. Yes, he has, with £2 to spare. So yes, he can buy 5 economy tyres and have them fitted. Now this is the OCW question. Said it many times, no harm saying it again. That doesn't mean write a story. All that means is put a few words together for each line of maths that you do, so whoever's looking at it can see what you're trying to do, and also be consistent with any units that's being used. Okay, question 3. Graham and Lisa go on holiday to Copenhagen in Denmark. They need to change currency between pounds and the Danish kroner. They both go to the same currency shop. Graham changes £200 and receives 1,800 Danish kroner, and Lisa changes £300 and receives 2,700. So that will give you enough information to draw a conversion graph. But first of all, you need to work out what the scale is on your graph. It's easy horizontally, it's going up in hundreds, but on this one you're going up in 50s to go from 0 to 500 in 10 little squares. They haven't reproduced very well, but there would be 10 squares there, so each square would be 50 kroner. So the first point that I can plot is to go across to 200 and then up to 1,800. So 200, 1,500, halfway between there and there would be 1,750. So 1,800 is one small square above. And then for £300 we want 2,700. That would be 2,750, so we'd be one small square down, because each small square is 50. And that line should also go through 0, because if you have no pounds, you're inevitably also going to have no kroner. So that should lie in a straight line. Whenever you plot points and then draw a line or a curve through them, it's always worthwhile making sure that the points are still clearly seen even once you've drawn the line. So don't do little dots, make sure it's a clear cross. Part 2. The Explain how the graph can be used to find out how many Danish kroner are equivalent to £700. So this is a popular question where they ask you to draw a conversion graph, or they give you a conversion graph, but then give you a value to find which doesn't fit on the graph. So there are many different ways of doing this. You could, in order to get 700, you could find 350 and double it, or you could find 300 and 400 and add them together. You could find 100 and multiply it by 7. Any one of those methods will work. I think what I'm going to do is find 350 and double it. So 350 mark it on my graph to show the examiner that I know what I'm doing, and then you read horizontally across from there. So 350 is equivalent to 3,000, and that's another 2 squares up, so that would be 3,100 DKK. So we would then double that to give £700, which would be equivalent to 6,200 DKK. And the examiner would have a degree of flexibility using whatever graph you've drawn and reading your values off. So if your value is slightly different to that, you'd still get the right answer as long as it was using the values from your graph. Question 4. In Tesco, potatoes are priced as £1.80 per kilogram. Sirloin steak is priced at £16.75 per kilogram. After buying a 2.5 kilogram bag of potatoes and a sirloin steak, I receive £8.80 change from a £20 note. What was the mass of my steak? So if we work first of all with the fact that I'm getting money back from my £20 note, the first step I would take is to find out how much my food cost. So the food costs £20 less my change, so I spent £11.20 on food. Now I've got enough information here to work out how much I spent on potatoes, because I've got the cost per kilo and I know the mass that I purchased. So the potatoes cost, the mass, which is £2.5 times £1.80 equals £4.50. So I know that my two items of food together cost £11.20 and the potatoes cost £4.50. So the difference between those two is what the steak cost me. £6.70. So I don't know the mass, I do know the cost per kilogram, and I do know what it cost altogether. So if I write it in the same way as I've written the potatoes up there, the mass was 2.5 kilos, I don't know what that is, times £6.70, times £16.75. The mass times the cost per kilogram must equal £6.70. So to find out what the question mark is, I have to do the opposite of multiplying by £16.75, which is dividing. So £6.70 divided by 16.75 is 0.4 kilograms. So it's not asking what's my mass in grams, so if I leave it as 0.4 kilograms, that's fine. Or you should know there's 1,000 grams in a kilogram, so that is 400 grams. I've written it like that just to try and give you an easy comparison with what you did when you were going from a given mass and a given cost per kilo to work out how much they cost. So we've got a direct comparison there. I don't know what the mass is, I do know what the cost per kilogram is, and I do know what the total is. That last part of that question was badly answered in the test. Most people got down to the £6.70, but very few managed to get that last part. Question 5, exchange rates. Where am I going? Question 8 to get the C. So, exchange rates. The dirham is the unit of currency in the United Arab Emirates. So we've got a buy and a sell. So if you want to buy dirhams to go, for every pound you spend you get 5.48, and when you're selling them back when you come home, you need to give 5.52 of them to get a pound. Lois goes on holiday to Dubai. She takes £350 in cash to buy the United Arab Emirates dirham. On the day she exchanges her money, the bureau has only 5, 10, 20, 50 and 100 dirham notes, so that's all they can exchange. Lois does not intend to spend more than £350, but she wants to buy as many dirham notes as she can. How much will Lois have left from her £350 after buying the dirham? Give your answer to the nearest penny. So the first thing to find out is what's the most she could possibly buy. So her maximum spend will get her £350 lots of 5.48. So she could get 1,918 dirham. But because there are no 1 dirham notes, she can't get 18 of them. She can get 15 of them because she could have a 10 and a 5 or 3 5s to make that up to 1915, but they couldn't then take it from 1915 up to 1916, 17, 18 because there are no 1 dirham notes. So the most she can have buy is 1915 dirham. So in order to work out now how much those are going to cost her, we have to go from dirham back into pound, which means you're going to be doing the opposite of timesing by 5.48. You're going to be dividing by it. But we're still dividing by the 5.48 because we're not selling that back. We want to find out how much she needs to spend to buy it. So 1915 divided by 5.48. which is that, which we then have to give to the nearest penny. So that's 2 decimal places. So that's going to cost us £349.45. Next digit over is smaller than 5, so it stays as that value. Then part 2. Kenny exchanged £1,000 for dirham. He then cancelled his holiday and exchanged all his dirham back to pounds. How much did he lose? So this is one where we're going to be using both values. First of all, to change into dirham. So he buys 1,000 times 5.48. 5480 dirham, and he sells all of those back. 5480, but he's selling them back now at the buyback rate of 5.42. Yes, 5.52, sorry. And because it's a buyback, it's going in the opposite direction, so we aren't multiplying, we're dividing. So that's £992.75, which is what he had back. Check the question. Does that answer the question? How much money did Kenny lose? No, that doesn't answer the question, because that's saying how much he got back. What he lost is the difference between the £1,000 he started with and what he got back. So he got back, he lost £7.25. Question 6. Pedro has kept a record of the total number of goals he scored in each of the 20 seasons that he played professional football. So there's 20 seasons represented in that table. Now I put this question in the test because it wasn't very well answered in Progress Check 1. First thing to do, take a row from the table and make sure you understand the context. What is the story that this is telling? Well, it's to do with the total number of goals in each of 20 seasons. So in 8 seasons, he scored 6 goals in total. In 2 seasons, he scored 7, and so on. So to calculate the mean number of goals, there were 3 seasons where he scored 4. So in that row, there are 12 goals scored altogether. There were 8 seasons where he scored 6 goals. So in total, there are 48 goals there. There are 14 here, 66 here, and 22 there. To find the mean, we want to find the total number of goals, which we get by adding those up, and divide by the count, which is how many seasons there are, which are 20. So the total goals, we can do it there on the table. It's often easier. Let's put the calculator back in. 12, 48, 14, 66, 22. 162 goals. So the mean will be 162 divided by 20 seasons. Tells us in the question. If it didn't tell us, we'd have to add this column up to find out what that was. So 8.1 goals per season. Question 7, income tax. Again, this wasn't well answered on Progress Check 1. It was better answered in this paper. So I've kept the question the same as it was in Progress Check 1. The only thing I've changed is the income. So there's no tax paid on the first 3,500 of her earnings. So everything she earned between 0 and 3,500 is taxed at 0%. Everything above 3,500 up to 10,500, so from there up to 10,500 is taxed at 25%. Everything above 10,500, so from 10,500 up to what she was earning, is taxed at 35%. So those are the three different bands and what the taxation is. Now, although I've written it 0 to 3,500, 3,500 to that, basically that's the subtraction that you need to make. So the first one is going to be 3,500 times 0. Well, anything times 0 or 0% is £0. So that's tax-free. For this one, you're going to work out what that difference is first of all. So 10,500 take away 3,500, which is 7,000 times 25%. Put that 25% in exactly as you see it. So that comes to £1,750. And then this gap, 40,000 take away 10,500 is £29,500, and 35% of that is taken as tax. So the total tax that's going to be paid by Loretta is the 10,325 on that portion of her earnings, 1,750 on that portion, and nothing on that portion. £12,075. Now, if you'd have put that in your calculator as 3,500 take away 10,500, it would just come out to be a negative value, which wouldn't matter so long as they were consistently negative, because what you're saying is that's coming off your earnings anyway. So don't worry about getting that negative in a knot. Right, if we get to that point, full marks, we've got our C. Question 8. A survey of 240 primary school pupils was carried out to find the amount of time they spent each week doing their homework. Here are the results of the survey. Let's get the story. Let's pick this one. This is saying that 60 pupils spent between 1 and 2 hours a week doing their homework, including 2, excluding 1. So if it was exactly 1 hour, it wouldn't be included there, it would be included in the one above. So pupils doing exactly 1 hour are in that one. Pupils doing exactly 2 hours are in there, and so on. So the first thing they want us to do is to draw a grouped frequency diagram of the data. A grouped frequency diagram is one that looks like this, with the bars connected. If it was a grouped frequency polygon, then it would look like this, where you plot the point on the midpoint at the maximum value and join them up. That's a group frequency diagram, that's a polygon. GF polygon, GF diagram. It's important you can tell the difference between the two, because of these 3 marks, they're both correct in representing that data, but if you draw the wrong one, the best you're going to get is 1 mark. The frequency, the number of pupils, always is vertical, and the range of the data is always horizontal. And we need to make sure that we can fill what's given to us here. So the maximum height that my bar is going to go up is 80. 10, 20, 30, 40, 50, 60, 70, 80. That works. And I have to go across from 0 to 5. 1, 2, 3, 4, 5. So it's not going to be a complicated scale to draw. Ten, 20, 30, 40, 50, 60, 70, 80, 0, 0, 1, 2, 3, 4, 5. I can put a 6 in there. Now, with any graph that represents data, it's important that you label it, and if you didn't, you would lose marks. So the height here, the vertical axis represents the number of pupils, and the horizontal axis, time taken, and the units, hours. So of those 3 marks, I've just earned 1 of those by a nice sensible scale and labeling. Without that, you wouldn't get those marks. Then to draw it, between 0 and 1, we're going up to 80. So we're just going to draw the bars now. And the next bar is going to touch this one, because once it's no longer 1, it trips into the next category. So there are no gaps with our bars. So then we have 60. Followed by 52. 32. And 16. And that's a group frequency diagram. The polygon, as I said, would have been one that had been across there and there and there and there and there, and no columns, and the crosses would have been joined with a ruler. You tend to find that they ask for group frequency diagrams more often than polygons. The final thing to mention with that is a common mistake is to put those 1, 2, 3, 4, 5 in the center of the columns, or even to write those inequalities in the gaps. That's not what you do. You label it just with the whole number values. Calculate an estimate of the mean time that the pupils spend each week doing their homework. So we're back to this grouped data table, and it's an estimate because I don't know my original values. I know there are 60 pupils that took between 1 and 2 hours, but what time within that they spent, we've got no idea. Because of that, what we do mathematically is we say that all of those 60 pupils are evenly distributed within that category, so they would average out at the mean value, the mid value. So all you need to remember from that is the fact that we take the mid value. So the mid value here is 0.5, 1.5, 2.5, 3.5 and 4.5. They don't always go up by the same amount, so it's important that you keep an eye on that. Now it's become the same question as that one there, where we're going to be multiplying to work out the total for each category. So I'm saying here that I'm working with 80 pupils, each spending 0.5 hours a week on homework. So to work out the total in that category, I'm going to do half times 80, which is 40. Then I'm going to do 1.5 times 60. So 1.5 times 60, which is, 90. 2.5 times 52, 130. 3.5 times 32, 112. And 4.5 times 16, 72. Then I need to find the total, which I get by adding those up. Again, nothing stopping you doing this on the table. The examiner will see the work on the table and be actively looking for it. So 40 plus 90 plus 130, 112, 72, 444. So the mean is going to be 444 divided by the total, which they're giving us in this question is 240. But if they didn't give it to us, we'd add up the number of pupils. So 1.85 hours. Now we want to check that that looks sensible, because one of the most common mistakes to make would be to divide by the number of categories. So you do 444 divided by 1, 2, 3, 4, 5, in which case you get an average time spent on homework of 2,200, no you wouldn't, done that wrong way around, 444 divided by 5. 88.8 hours. Well, the maximum there is 5 hours. So if you get an answer like that, you should immediately be thinking, hang on, something gone wrong there. 1.85 hours is in this region, which is where most of the responses are. You've got your modal value there. So you'd be expecting that to look about right. The median value, if they'd asked for that, would be halfway 120. Your first 80 are there. You go beyond the next one, that would take you to 140. So 120 is in there as well. So the modal is 0 to 1, the median is 1 to 2, the mean is 1.85. They're all there or thereabouts similar. So I'm pretty confident that that's correct. Oh, I've just answered that. I didn't realise that was coming up. So the median value is the 120th value, because it's half of 240, and the 120th, 80 takes you to there, 140 takes you to there, so it's 1, which is less than t, which is less than or equal to 2. Question 9. Where's my B coming from? Question 11. Okay, so for question 9, we've got some triangle, we got some parallel line, we got some straight lines. So it's angle properties of triangles, parallel lines, and straight lines. And what we want to find, given these two, is what that one is there. Well, I need to get inside this triangle, and my path inside this triangle is the fact that I've got a straight line there. I should know that angles on a straight line add up to 180. So to work out what that missing angle is, I'm going to do 180 take away 116. Tells me that's 64. Now, I'm then on a parallel line. And with parallel lines, where you have a line crossing like that, these angles are called corresponding angles. They correspond, they're in the same place on each of the parallel lines. Corresponding angles are equal. So if that's 116, that would be 116 there. Or if that's 64, that's 64 there. So if I know that that is 64, I know that that is 64. That then means that in this big triangle, I know 2 out of the 3 angles. I know that that one is 51, I know that that one is 64, and that's the one I want to find. So my triangle knowledge with angle properties tells me that angles inside any triangle have to total 180. So to work out what x is, I have to do 180 less 51 less 64. Which is 55 degrees. So that's 55 degrees. A common mistake I saw when I was marking this was that people assumed that these triangles were isosceles, and if that was 64, that one is 64, or if that one's 64, that one's 64. If it doesn't tell you it's isosceles, and it hasn't got the little lines on it, then it isn't isosceles. You can't assume so. Also, I did see during the test people trying to measure those angles with a protractor. When you see it's not drawn accurately, you can't do that. Question 10. Show clearly whether the following statement is true or false. If you increase a positive number by 10% and then decrease that new value by 10%, you get back to your original number. If they don't give you a number, pick one. So let's say we're going to work with 5. Could be 50, it could be 500, could be whatever you want to use. It doesn't matter as long as you stick with that. A 10% increase by 10%. So what you could do now is find 10% of that, add it on. But what I'm trying to encourage students to do is to work with the percentage multiplier. So for a 10% increase, the multiplier will be your original amount's 100, you're increasing by 10 is 110% of what you started with. So 5 times 110% equals 5.5, which is what you'd have got if you'd have found 10% and added it on. I accept that, but getting used to using multipliers makes the reverse percentages and compound percentages much easier to deal with. So then we've got a 10% decrease. Well, the multiplier for that, you're going to start with your original 100 and then take 10% off it. So what this is saying is if I then decrease this new value, 5.5, by 10%, I should get back to 5. So 5.5 times 90% gives you 4.95. Well, 4.95 is not equal to 5, so it's false. So multipliers are good. They're good to get your head around, but you could have got 4 marks out of 4 there by finding 10% and adding it on, and you'd have got 5%. Then find 10% of 5.5 and subtract it, and you'd have ended up with 4.95. Question 11. A company offers its workers a choice on how much their salary will increase next year. Each worker can receive either a £500 increase or a 2% increase on their present salary. Janet is currently on a salary of £24,000 a year. Which option should she choose? Well, what we want to do is increase. We know exactly that's going to be a £500 increase, so we want to work out how much she gets if she goes up by 2%. So if we work out what 2% of 24,000 is and compare it to 500, we will know. So 24,000, 2%. Oops. 24,000 times 2%, £480. So a 2% pay rise is going to give her an additional £480 a year, so she's better off accepting the £500 increase. Question 12, cumulative frequency. The birth weights of 120 babies were recorded, so the total for this comes to 120. The cumulative frequency diagram shows the distribution of the weights. Write down an estimate of the median weight of 120 babies. So the median, halfway, middle, so we're looking for the 60th baby. So the way that cumulative frequency curve displays this information is it builds up all the data from 0 up to the 120. So we go up cumulative frequency to 60, and then read this value off the graph. So marking on the graph, I'm showing the examiner I know what I'm doing, and I've got a weight of 7.12345 so it's about 7.6 pounds. LB, short for pounds. Write down an estimate of the number of babies whose, oh sorry, I missed that, this one is 7.6 pounds. This one is the interquartile range. So the interquartile range is the range of weights in the middle half of the data. And we have to draw two more lines on the graph to do that. The first is the lower quartile, which is the bottom quarter of the data. So if there is 60 to halfway, if we half that again, we get 30. That would be a quarter of the data. Half and half again for a quarter. That's what's called the lower quartile, or LQ for short. So the LQ, lower quartile, is 6.7. Then the upper quartile is a quarter above that. It's 3/4 of the data. So that's going to be 90, 60 and 30. That's the upper quartile. We read that off the data, and that's 8.1234. So the interquartile range is the difference between those two values. So 8.4 less 6.7, 1.7 kilograms. Pounds, sorry. So that's your interquartile range. Write down an estimate of the number of babies whose weights were greater than 9 pounds. So to read off the cumulative frequency graph for 9 pounds, we will go across to 9 and read in the opposite direction. So we're reading this way and reading across to there. But what that value tells you there, and it's going up in 2, so that's 106. What that value tells you is the number that are less than 9 pounds. Because this is asking for greater than, what you're actually looking for is the number of babies that are in the gap between 106 and 120. So it's in fact 14 babies. Okay, so when you read this way off a cumulative frequency graph, it always tells you less than. Question 13, box and whisker plots. So the following box and whisker plots show the flow of water through a drain measured in cubic meters per second. The flow of water was measured at 11 AM each day for the first 5 months of the year. So that's the box plot for January, February, March, April and May. Now with a box plot, the two extreme parts, which are called the whiskers, tell you what the minimum value is. So the minimum flow of water through the drain in January is that value. The maximum was that value. Nothing was above and nothing was below. Each part of the box, so from the whisker to that part to that part, that part to that part, each of those represents a quarter of the data. So a quarter of the readings were in there, a quarter of the readings were in there. So between this part, half the readings exist. That line is where the median is. That's your lower quartile, that's your upper quartile. So these parts correspond to the information you would get off a cumulative frequency diagram. So in which of the 5 months was the median flow of water the greatest? So the flow of water increases as we go up the graph. 30 cubic meters per second, 50 cubic meters per second, it increases. The median value each time is the line that cuts the boxes. So that one, that one, that one, that one, and that one. So we're looking to see which median value is the furthest up the graph. So you can either do it by eye or move along the graph with a ruler until you meet the last one. The last median value is there, which is in April. In which 5 months, which of the 5 months was the range of the flow of water the greatest? So range, I mean basic averages work, is the largest take away the smallest. So where the gap between the top of the whisker and the bottom whisker was the largest will have the greatest range. And I think you can see quite straightforwardly from this graph that January has got the largest gap between the minimum value and the maximum value. Iona is writing some statements for a report on the flow of water through the drain. Complete each of the statements given below. Both the upper quartiles and medians in the months of blank and blank were the same. Upper quartiles and medians. So these are the upper quartiles, these are the medians. So it stands out quite clearly. It's January and February where they have the same median and the same upper quartile. 25% of the results in March show the flow of water was greater than blank. So quarter of the results in March show the flow of water was greater than blank. So we're looking in this one, and we want a quarter of the data to be more than something. So all of the data was more than 20. Sorry, yes, all of the data was more than 20. At this point, you've got that quarter, and that quarter. So 3/4 of the data, or 75%, is more than 26. Then we come to that. Half of the data is more than that value. A quarter of the data is more than this value, and that's what we want, is 25% of the data is more than, and it's more than that value there, which is 43. So a quarter of the data in March is more than 43 cubic meters per second. Circle either true or false for each of the following statements. 25% of the results in January show the water was less than 6 cubic meters. So in January, there's our 6. Well, none of it was less than 6 because the minimum value is 6. So that's false. The units, cubic meters per second, measure the volume of water passing through the drain each second. That's true. The mean flow of water in April was certainly greater than 36 cubic meters per centimetre. So let's have a look. April 36. So let's find 36. 1, 2, 3, 4, 5, 6 is there. So that's my 36 line. And it's saying the mean flow of water in April was certainly greater than 36. Well, more than half the data is above 36. That line hasn't come out very clearly there. There's 36. A quarter, a half, more than half the data is above that. So that will certainly be true. And the month with the greatest difference between the lower quartile and the median was May. So the month with the lowest difference between the lower quartile and the median, so the gap there, lower quartile, median, that's the same. The lowest gap, the smallest gap, is May. That's true. Question 14. Sorry, I just got that last one wrong then, didn't I? The greatest difference between the lower quartile and the median was May. That's false. That's the least difference between the lower quartile and the median is May. So the greatest, that's false. Now, if that was in an exam, as long as you did that, so it was clear to the examiner that you actually meant that one, because that's the only one, that's the only circle you've coloured in, then that would be fine. So it's false, true, true, false. Then we come to a couple of percentage questions that appear quite late on in the paper. And what I've been trying to push in lessons with this is that you should be looking for these questions. If you have got a percentage question late on an intermediate tier or early on in a higher tier, it's probably not as easy as it looks, and it's probably a reverse percentage question. Once you've got that and you're thinking, right, okay, I need to be a bit careful here, the next thing to look at is what they are looking for? What do they want you to calculate? If it's an original value, that certainly means you're talking about a reverse percentage. The shop has reduced the price of a bicycle by 40% of its original price. The sale price of the bicycle is £192. So after that reduction has been applied, that's what it costs. And what they want to know is what was the original value. So if it's been reduced by 40%, that means the multiplier will be the original amount is 100 less 40 equals 60%. Now I'm writing that down so that it helps me explain it to you, but once you're used to this you can just write that bit in your head. It's the next bit that's important. So what we're doing is we've got an original value that I can't spell. It's being multiplied by 60%, and the output, the outcome of that 60% reduction is the sale price. So what we have to do is go backwards in order to work out what that original is. And when you go backwards through a number machine, you do the arithmetic opposite. So we do the opposite of multiplying by 60%, which is dividing. So you do 192 divided by 60%. $320. And you can check that. You could use your more comfortable method if you like. Say, okay, well, if that's true, so if I find 40% of 320 is 128, and if I take that off 320, I get 192. I've got it right. I know it's right. But you have to be looking for the trigger there. It's in the second half of the paper. It's a grade B percentage question. Same with this one. What was the cost before? Another way of saying original. Cost for the bill for repairing a washing machine came to £151.68 inclusive of VAT. That means the value added tax has already been added on. What was the cost before it was added? When tax is added on, it increases the value. So it's not reducing by 20%, it's increasing by 20%. So the multiplier will be your 100%, your original value, plus 20%. So my number machine, that's what I want to find, times 120% gives me a price of £151.68. So to work out what that is, I take my 151.68 and divide it by 120%. And I get £126.40. Check it's right, times it by 20%, 25.28, add that on to my £126.40, and it should give me 151.68. I know I'm right. 6 marks there. Not many people picked up marks on those two questions, just because you didn't look for reverse percentages. And the final question. error bounds, upper and lower bounds in measurement. So what have we got? A stylish computer desk made of laminate wood, non-scratch top, length is exactly 2000 millimeters. Luke wants his new desk for his bedroom. The design is to fit on the straight wall between his wardrobe and his bookcase. So we've got a flat wall, we've got a wardrobe there, bookcase there, gap in the middle. He wants to slot his desk in that space. Luke has measured the length of the wall, which is 600 centimeters, correct to the nearest 10 centimeters. Bookcase, which is 147 centimeters, correct to the nearest 1 centimeter. The wardrobe, which is 250, correct to the nearest centimeter. So it's a rounding question. Again, if this is in the second half of an intermediate paper, you should be expecting an upper and lower bounds question and know how to deal with it. So the length of the wall is 600 centimeters. If it's rounded to the nearest 10 centimeters, then the upper and lower values will be 5 either side of that. The error bounds will be plus or minus half of that. So 5 centimeters below it would be 595. 5 centimeters above it will be 605. Everything between that is, if it's rounded to the nearest 10, will become 600. So what is the greatest possible length of the wall? 605. Even though 605 would round up to 610, when we're working with upper and lower bounds, we use both those values to define where the middle is. The bookcase, which is 147, correct to the nearest 1 centimeter. So if you've got 147 there, the tipping point either side of that, which would round to 147 rather than 146, is half a centimeter either side. So you take your nearest centimeter, divided by 2, plus or minus 0.5. So below, it'll be 147.5, above, 146.5, and above 147.5. And the distance between them is a centimeter, which is why it becomes that. The distance between there and there is 10 centimeters. So that's how you use these values to work out the error bounds. What's the least possible length of the wardrobe? We didn't need to work with the bookcase yet. So for the wardrobe, it's 250 to the nearest centimeter. So it's going to be 250 plus or minus 0.5. For the least possible, that would be 250 minus 0.5, which is 249.5, which is that one. Most common mistake people would make there is to say, well, it's 249.49 because 0.5 rounds up. That isn't right, because that could be 249.499, which is bigger than that value. So that's why we take the two extremes as the upper and lower values. Part C. Can Luke be certain that his desk will fit in the space available? You must show all your calculations, give the greatest or least bounds of any measurements used in the calculations or comparisons, and give a reason for your answer. Well, what would be the worst case scenario? Well, the worst case scenario is if that wall was as narrow as possible. So if you had the minimum length of the wall, and you had the maximum width of the wardrobe, if that was as wide as possible, the bookcase was as wide as possible, and the desk was as wide as possible. Well, we know the desk is exactly 2000 millimeters, So if we had the maximum wardrobe length, and the max length bookcase, now this is telling us that the desk is exactly 2000, so that hasn't been rounded. The length of the desk, if it's 2000 millimeters, in centimeters, there are 10 millimeters in a centimeter, so we divide that by 10, we have 200 centimeters. So if the gap between the minimum length of the wall and the the wardrobe and the bookcase is smaller than 200 centimeters, we can't be sure. So worst gap would be, so the minimum length of the wall is 595. The maximum length of the wardrobe is going to be 250 plus 0.5, which is 250.5. And the maximum length of the bookcase, so 147, maximum length 147.5. So the worst gap, the worst possible gap, or the smallest gap, probably better than worst, 595 less 250.5 less 147.5. If that comes to more than 200, it will definitely fit. .97 centimeters. Which is less than 200 centimeters, so no, Luke can't be certain as the gap could be up to 3 centimeters too narrow. It can't be any more than that because we've taken the worst case scenario for that gap, where the wall is as narrow as possible. So we've taken the minimum value for the wall and we've made those two pieces of furniture as large as they possibly can be. So there you go. That was progress check number 2.